Greetings, everyone, and thank you so much for joining today's webinar. Today, we're going to be discussing advanced array microphone applications, talking about voice lift and sound reinforcement. But before we get into that, just a few items for housekeeping. First of all, this session is being recorded and will be available for on-demand viewing. It usually takes us about a week or so to get it edited and available for public consumption, but once it is ready, it will be available at shure.com/webinar. Once again, that's shure.com/webinar. You can also find all of our upcoming webinar sessions listed there, and you can see all of our past webinar archives. And we have a ton of great webinars across a lot of audio topics. So please feel free to go to shure.com/webinar, see all of our past events, and you'll also be able to view this one in about a week or so. Then second of all, as we go through the session today, please feel free to type any questions you have into the questions section of your web app. If you can't find that, I think you just need to look for a little question mark and a circle. If you're using the control panel, just look for a dark gray toolbar with an orange box with a white arrow. Click on that orange box. You'll be able to get to the Q&A section there. Type any questions you have, but please be patient. We will be holding on those to the end of the session. So let's take a look at what we're going to be looking at today. First of all, we are joined by two fabulous panelists today, Mr. Ben Cook and Mr. Chris Lyons, and they are going to give us all of these great details and information about voice lift and sound reinforcement. And here's our agenda. So we're going to start by talking about voice lift versus sound reinforcement. Then we're going to do a little math. Don't mind me if my eyes glaze over during that section. After that, we're going to talk about zoned sound systems. We'll talk about some additional options, and then, as I mentioned, we'll dive into the Q&A. So without further ado, let's get into the good stuff. Take it away, gentlemen.
Thank you very much, Cheryl, and welcome everybody. And we're kind of assuming that if you're interested in voice lift, you might be an end user who's got a meeting room, or maybe you're an installer and system integrator who has to put these things in. But either way, I think we'll have some interesting information for you today. So first of all, though, let's talk about one thing, which is, why do we even need voice lift? Why are we even talking about this? So let's go to the next slide there. And the real problem is that in a large room, it can be difficult to hear people. And the obvious cause is, of course, the distance, so that when we're in a big lecture hall or something like that, somebody's just a little too far away to hear. But also directionality plays a part. And I'm not talking about microphone directionality. I'm talking about the directionality of the human voice. When we speak, especially the mid and high frequencies tend to travel forward from the head and not to the sides, not to the rear. So if in a lecture hall or a training room, you happen to be seated to the side of somebody or to the rear behind them, someone's asking a question, it can be pretty difficult to understand what they're saying. And that's why you always hear someone in the back saying, "Can you repeat the question, please?" to the instructor or the presenter or whatever. And that works, but it kind of gets annoying after a while. So the ideal situation would be if everybody can just hear everybody, and that's what voice lift is all about. So let's go ahead here, and let's also, Ben, we need to distinguish between sound reinforcement and voice lift, because they're sort of two different flavors of the same thing here, right?
Yeah, so with sound reinforcement, what you're really trying to accomplish is you're going to have one presenter and you're talking to many people, right? So it's a one-to-many. Whereas voice lift, it really is about being involved in the meeting, right? So it's a many-to-many, and the difference there is distinct, right? And we need to make sure that we're not trying to do voice lift in a sound reinforcement application, right?
Yep. All right, let's go to our next slide here. And we'll talk a little bit about sound reinforcement. And as Ben said, this is the classic one-to-many. Acoustically, though, people in a sound reinforcement scenario, they know they're listening to a PA system. They can hear that the sound's coming out of loudspeakers. They may or may not, based on the size of the room, be hearing very much acoustically from the presenter. It depends. But the typical microphones that get that job done are handhelds, goosenecks, lavaliers, maybe a head-worn mic or something like that. But Ben, there's always some drawbacks to that, right?
Yeah, exactly. And I think over the last couple of years, we kind of got hit by the biggest, right? Which is sharing things maybe isn't as prevalent as we would like it to be today. Me breathing and spitting on something and handing it to someone else in a meeting might not be ideal. Even having just a handheld pre-COVID, after COVID doesn't matter, right? You're kind of limited in where you can move, what you can do. Maybe you're wearing clothing that doesn't allow for a lavalier that we're going to clip onto it, right? And maybe we want to move around the room and we don't have a wireless option in that room. So there's going to be other ways to do it, but these are the biggest drawbacks of a standard sound reinforcement system.
Yeah, it used to be everybody just assumed that they'd wear or hold a mic to give a presentation, but now there's a little bit of resistance to that, and people would prefer not to in many cases. So we'll talk about that too. Let's go to the next one now with VoiceLift. As Ben said, it's a many-to-many scenario here, and you see this mostly in boardrooms with a really long table or a lecture hall or a training room. And there's a lot of benefits, Ben, to having everybody be able to hear everybody else, right?
Yeah, and you can't participate if you can't hear, right? If you don't know what's going on at the far end of the room, chances are you're going to be able to see the screen, but if you can't hear the talker, it's all going to disappear, right? And you're not going to participate. You're not going to be able to contribute to that meeting, and essentially half the room will be wasting their time, right? In the past, these VoiceLift systems, we would do them with mics either hanging from the ceiling, like an omnidirectional mic, or we do some goosenecks and those kind of things in the back of the room where you could have an additional VoiceLift system. And we can still do that, but there are better solutions.
Yeah, I can remember when I was working in the applications engineering group here at Shure years ago, and one of the questions that would come up once in a while from an installer would be, how do I mount gooseneck mics or boundary mics on the back of theater seats or in the armrests or something like that? And in a larger room, you could easily be talking about 100 microphones, which was a real headache in terms of cabling and mixing and powering. And, and it was all just because we want to hear the questions that people are asking. And, with ceiling microphones now, we've got a better way that's a lot easier. So let's talk about that. So room requirements, the room always matters. We try never to forget that the room is part of this whole scenario here. It's a part of the sound system. And so we'd like to be able to do VoiceLift in a room with reasonable room acoustics, not significantly noisy, not too much reverberation. If you're taking measurements, maybe a background noise level below 45 decibels, but the quieter the better, obviously. And we say a minimum room size of at least 40 by 40 feet.
Okay, so based on that, why wouldn't you be able to do this in a smaller room?
Well, that's a great question. So the reason we quote a minimum room size and not a maximum room size is because in a smaller room, you should be able to hear each other acoustically. There really shouldn't be that difficult in a room that's 20 by 20 to hear the person at the other side of the room. If you are having trouble hearing each other, it's likely that there is some other problem that's going on, like an excessively loud HVAC system, or really poor acoustics and reflections from a lot of glass and hard surfaces and so forth. Those things probably need to be fixed on their own, and they're going to make it extremely difficult to provide any kind of amplified sound in the room anyway. So we say
if you're sitting 25 feet away and can't hear each other because of the HVAC, maybe we should fix that before we try and do VoiceLift. Right.
Exactly. So as a rule of thumb, figure if the room is 40 by 40 or so, then you might have people that are 30 feet or more apart. And that's when, all other things being equal, it might be starting to get difficult to hear people, especially if they're all facing the front of the room. If depending on the seating plan, if the room is very quiet, maybe they don't have any trouble hearing each other in a room that size. But you never know. Every room is a little different.
But we can't look at VoiceLift as a solution to fix a bad room, right?
Right.
It's there to provide coverage so that you can hear everyone in the room, not repair some of the issues that we would like to fix before we attempt to do this, right?
Exactly. Yep.
Perfect. So
All
what do we
right.
need to do?
Yeah, so in terms of the audio system requirements, you do have to have your system kind of set up and designed in a certain way. The most important thing is you need a zoned sound system. You know, it's not just a single zone, it's multiple zones of microphones and loudspeakers, and we'll talk about that in more detail. An automatic mixer is pretty much essential here because you're going to have multiple microphones or pickup lobes, and you can't leave them all live all the time because that ends up detracting from the sound quality. A key part that a lot of people don't think about is a matrix mixer, which is the part of the mixer that does the signal routing that says, okay, microphone one's going to go to zone A and microphone two is going to go to zone B, and all those sort of cross points are important, and depending on how many zones you have, it can get pretty complicated. So the matrix mixer is controlling the air traffic control of which sound source is coming out of which speakers. And that also means that we need to be able to address each of those loudspeakers individually. So we're going to need dedicated amplifier channels for probably an individual speaker, or at least a pair or a small group of speakers. So you're looking at a multi-channel amplification system, not just one output with 8 speakers on the line.
Right. So it is a little more complicated than your standard video conference system, but it's not something that is out of reach for many, many installers out there, right? Just takes a little bit of work and maybe some education.
Right, and especially now in the days of networked audio, it's a lot easier to handle multi-channel audio systems and easily control the signal routing, where you want it to go, and the gain levels and all that. So it's easier than ever to do this.
Right, because I think for the layman, this might start getting a little scary, but I think as we walk through here, you can see it's not that complicated when you take a step back. When you're digging into it, it feels like it sometimes, but I think we've got some products and solutions here that are going to make it much easier. So, all right, I'm looking forward to seeing how we do this. Yeah,
all right. So microphone requirements, well, of course you need a really good Shure microphone. Could it be any other way? No. So the microphone needs to have really precise coverage control. And by that, we mean that you need very narrow focused pickup lobes, number one, so that you are not picking up bleed from adjacent loudspeakers. And number two, you need to be able to precisely position where that lobe is pointing, so that it is picking up the right people and not picking up the loudspeakers. So the MXA 920 is a great candidate for this because you can precisely position those pickup lobes and they don't move. They stay where you put them. And the MXA 920 has steerable coverage mode, which is what enables this. If you've got some other type of microphone that just has one large coverage area, that's not going to work for this. Or if it's got some sort of automated moving coverage area, that's not going to work either, because you can't really control where it's going to point because it's going to be searching.
So on our product, on the MXA 920, we would take it out of our automatic coverage mode and make sure it's in that steerable mode, because we would never want a mic to open underneath one of those loudspeakers. Essentially, exactly. That's what it comes down to, right?
Yep. And that's really the precision coverage is how you're going to deliver sufficient gain before feedback without picking up yourself from the loudspeakers. And you want the microphone to have multiple talker capacity. And by that, I mean, it needs to be able to activate multiple lobes pointing in different places at the same time, because it's entirely possible that you'll get into a situation with back and forth dynamic conversation between an instructor and students, or two people at the end of a table. And so it can't be a case of we hear this person or that person. We may need to hear both. And the mic needs to be able to deliver that. And then finally, individual channel audio outputs here. So, let's say you've got 8 pickup lobes from the microphone, you're going to need to route those individual lobe audio channels distinctly. And so you can't have a mix output. You need individual channel outputs that you can then appropriately mixed to the different zones as necessary.
And we need those individual channels because we have to put in an echo cancellation on each one, right? That's the recommended method to make sure we don't get any of those loops.
Exactly. Yep.
Right.
And then finally, we can't forget about mounting options, because in some rooms, you might have ceiling tiles and you're going to mount the microphone up there. Other rooms have some different kind of ceiling. You might want to suspend it from a pole or suspend it from wires or whatever. There's a million different options here. And so, you want to definitely pick a microphone that gives you plenty of options to adapt to the ceiling structure that's there in the room. And the 920 gives you a choice of several different accessories for everything from a drywall ceiling to a drop ceiling to no ceiling.
Right.
All right. So what are the advantages of using ceiling array microphones for sound reinforcement and voice lift? Well, as we've mentioned before, a touchless solution these days is really what people are really enthusiastic about. The fact that they don't really see it or notice it, and certainly you don't have to pick anything up and clip anything on, is a huge plus these days. And for an instructor or a presenter, the fact that you can move around the room, you're not stuck behind a podium or sitting at a desk or anything like that. You can go where you want to go and always get picked up. That is ideal. And if you're a student or someone in the audience at a lecture, the fact that you can ask questions freely without waiting for a microphone to be passed over to you or without getting up and going over to a mic stand in the aisle or something like that, all those things really make this much more comfortable and lower the barriers for communication. So it's easy to use and flexible. And Ben, the amount of amplification that we're talking about here is really 10 to 13 dB of sound pressure level. That's the amplification that a 920 can give you in a voice lift situation. And that's actually quite a bit, right?
Yeah, so you're looking for 10 to 13 dB above the sound floor in the room. So that's going to give you the ability to hear all talkers individually. And the 920 is really the first one the 910 could get us there. The 920 is going to get us there with headroom because we've narrowed the beams down. We're able to get 3 dB more of output from the 920 than we could in the past with the 910. All these advantages here of the ceiling array microphones that we're talking about are advantages for the end user. We haven't even talked about the advantages for the installer, where we've got a single cable installation now. We have those all of those mounting options available directly. So now we've really simplified the process for what used to be a really complicated solution.
And if you haven't ever been in a room that's equipped with voice lift, it's a really interesting experience because you may not really realize that there is any sound system. If it's really working right, the effect is so subtle that you can hear other people talking, but you don't really realize that there's any help from the loudspeakers. And it's only when somebody turns it off that you say, oh, yeah, I guess I was hearing something from that speaker. Right. I just didn't really know it. So it's not like you're getting blasted by a PA system. This is a very subtle effect, and people just know that, boy, in this room, I can hear everybody and they can hear me. I'm not really sure how that happens, but I love it.
Right, it really is subtle, and you pointed out there that a lot of times if you've got a great voice lift system, no one will know you're running a good voice lift system, right? It's only until you turn it off and people go, oh, wait, there was something here. And it's the absence of it is what tells you the system was tuned properly. So it's not like you're never going to look up in the ceiling in a voice lift room and go, oh, that speaker's on. That's not what you were looking for. It needs to be more subtle than that.
Mm-hmm. And it doesn't take a lot of amplification to deliver that, which is why 10 to 13 dB is more than enough. In some cases, you may only need 6 dB of amplification. Right. But the fact that we give you plenty of additional capacity means you can do this well and do it in more rooms than you've been able to do in the past. I remember in the early days of this, you had to have a room that was basically like a library, that was completely covered in padded surfaces with, almost no reflections at all. And it was only practical and affordable in a high-end boardroom. You couldn't do it in every classroom. It just wasn't worth attempting.
Right.
But now we're able to spread this to more rooms in more facilities, and people are really enjoying it.
Fantastic.
All right, let's go on here. Okay, the math. Now, don't worry too much. Ben and I didn't get past the 6th grade, so we're going to keep this as simple as possible. But we'll talk a little bit about the math behind this here, because there are some ways to kind of predict how VoiceLift will work in your particular facility. So let's go ahead here. We can't forget our old friend, the inverse square law, which basically tells us predictably at a certain distance away from the source what's the sound level going to be, because the inverse square law tells us that there's a 6 dB drop in level for every doubling of the distance from the source. So if we know how loud a particular talker is, or an average talker, which we do, we can say, well, if people are 30 feet away, then the level's going to drop by X, and at that seat it's going to be this loud. And so that tells us, well, that's less than we'd like, so how much do we need to make up? That helps to tell us what the need for acoustic gain is going to be. So let's go ahead and go forward, and we'll talk about the equation a little bit.
Well, and I do want to point out too that the inverse square law there is no compensating for what speaker you're using or how it's being used. This is just physics, right? And we're going to go into PAGNAG here on the next slide. Chris is going to explain. And there is some things here that are open for interpretation, right? Whereas with the inverse square law, that is a law, right?
Right.
PAGNAG is not a law. So let's go into this here.
We haven't found a way to get around the inverse square law yet, but
no, not yet.
Maybe when we populate other planets, we'll find it's different there. Who knows? So the potential acoustic gain equation has been around for many, many years, but the equation basically assumes that you've got omnidirectional microphones and loudspeakers. There's no term in the equation that lets you factor in the fact that you're using a cardioid mic, for instance, or a speaker with a directional pattern or anything like that. That just makes it too complex, and there's no correction for room acoustics either.
Right.
And because of that, the PAG equation is quite conservative and just kind of gives you is this even feasible sort of thing. Now, what we've done is, through lots and lots of trial and error and experience with people doing sound reinforcement and voice lift with ceiling microphones, if we go to the next slide here, we've been able to come up with a worksheet that factors in the greatly superior directionality of a ceiling array microphone and the fact that you're doing multiple zones so that there's more separation between the components. So Ben, how does that sort of adjust the numbers here for us?
Yeah, so you take a look, if we do, we talked about earlier how we need to do multi-zone, right? So if we do a single zone of voice lift, that's essentially taking my voice at one end of the table and amplifying it to the other side of the table, right? There's no back and forth. And with a standard omnidirectional microphone, in the room that we're going to show you that we used an example, it's a room that would be barely large enough for voice lift. With the omnidirectional single zone, we would never be able to accomplish it. The MXA 920 will give us about 7 dB above the noise floor in that single zone, but we need about 13, 14 dB of pickup in that zone. Now, if we do a multi-zone where one end of the room is being amplified to the other end of the room and vice versa, because we've got that separation and because we've got that additional directionality from our MXA 920, we can actually accomplish about 12 dB more acoustic gain than we would get out of an omnidirectional microphone. So in this example, this room would work. We can get 15.5 dB of audio pickup in that room, and we need 17 to overcome the sound floor, right? So our gut here, and this is our gut check for the PAGNAG calculation, is yes, it will work in this room. Now, once we go to install them, we just need to make our adjustments to fine tune it to that room. But this is our great starting point to let us know that it is an option for this room.
And just to clarify, you misspoke. You said 17 is the needed acoustic gain. In
Sorry,
that multi-zone, it's 14. So
right.
we'd like 14. We can generate 15 and a half, so we're good. We've got more capacity than we need.
Absolutely.
So this multi-zone thing and this voice lift calculator lets you kind of predict, given the distances that we're looking at in this room, given the seating layout and dimensions of the room and so forth, is this a feasible plan? And it's great that in many cases it will be.
Right.
All right, so let's go ahead and look at kind of how these zoned sound systems get laid out and configured here. So first of all, let's take a look. This is kind of the concept of a zoned sound system in that sort of long boardroom table sort of environment that we're talking about. So basically, as Ben said, you got one mic at one end of the table, with multiple zones that are feeding out of the loudspeakers at the other end of the table, and vice versa. Obviously, depending on the room, you might have 4 zones or, and 4 mics or whatever. And we should also probably point out here that this gets a little bit confusing, but we've got 2 separate microphones here. It's possible in some rooms that you might do this with one microphone, where the mic might be in the center of the table and you've got 4 lobes pointing to one end and another 4 lobes pointing to the other end. That's okay. That may work out just fine given the distances. So you don't always have to have separate microphones, but in a larger room, you might want them. And so for people who think of these things in 2D, it's always helpful to have a system diagram. So this is kind of how the input and signal flow would work. So you've got basically your mic channels. Those are your 8 lobes there in the orange and the green. They're going to go through the automatic mixer that's handling the gating and the activation of the microphone lobes. Then from there, they go into the matrix mixer, which is controlling the routing so that we know which ones go to which loudspeaker channels. And in this case, we've got 2 amplifier channels for our 2 zones, and the audio goes to each zone accordingly. So with an MXA 920, you could do it with one mic, you could do it with multiple mics. It's pretty easy to make it happen. Now, you can also do video conferencing at the same time that you're doing voice lift. In fact, in lots of rooms nowadays, video conferencing is sort of a given. It's a must-have. So you may want to have a video conferencing room in a lecture hall or a big training room or something like that, and also be doing voice lift, and that's perfectly okay. You can manage that. The key is that you still need to have an acoustic echo canceller reference so that the far end audio is being fed into the automatic mixer and the echo canceller so that it knows what it's trying to cancel, and that the automatic mixer doesn't activate microphones for some far end voice there. So it starts to look a little hairy on paper here, but if you're an end user, don't worry. This is the integrator's job to manage all this. They're going to be doing all the signal routing.
And there are tools now where we don't need to see all these routes. They're all done automatically behind the scenes. So this is kind of good, and it's got a good segue for where we're headed.
Yeah, speaking of which, so how do you actually lay this out and configure all this, Ben, when you're doing this?
Yeah, so the first thing I'm going to do here, and again, guys, this is a very simple design, right? So I don't need my inbox blowing up when we get off this conference saying that that was too simple a room and the math didn't work. These are examples, and you're going to see exactly what we're talking about and how easy these things can be to do. Now, if we're talking about sound reinforcement with an MXA 920 and some ceiling speakers in a room, we're not going to be in a conference environment, right? It's going to be more of a classroom style. So we've got our mic and our speakers in this room. The mic, if I click to the next one, the mic is going to show our pickup area here at the front of the room. And then that is being transmitted through the whole room to make sure the audience is covered. We'll go on to the next slide, and I'll show you how this would be routed in our designer software. We simply have the MXA 920 coming into our DSP, which is our IMX room, and then out to our MXN5C ceiling speakers. Now, if we're going to do a voice lift room, we're going to do things a little bit different because this is going to be separated into zones, and this is more of a conference as opposed to a presentation style. So you can see we've got a mic at each end of the table along with 4 ceiling speakers here. So if we click to the next slide, we've got zone 1, and then we also have zone 2. So we're going to transmit the audio from zone 1 that's picked up here, and the audio that's picked up from zone 2 into each other's zones. So as we click through here, you'll see that the audio picked up from zone 1 transmits into zone 2, and vice versa as we click through. Zone 2 also transmits into zone 1. So how do we connect this? We're going to have both of our MXA 920s operating in steerable coverage mode with individual outputs into our IMX room, so that they all have AEC reference channels, and then out to our loudspeakers. And we're going to take an AEC reference from each loudspeaker back to the mic, so that it knows which part of the room it's kind of listening to, right? That's the easiest way to explain it. There is a little bit more routing that has to go into the matrix mixer that's built into IMX room, but this is how it would look in Designer in a very simple 2-zone voice lift system. There was one I missed there. If we go back one, so this is just that representation of one side. Zone 1 is going out zone 2's speakers, and zone 2 is going out zone 1's speakers.
So there are a couple other things that we do need to take into account here. And, as we mentioned at the top of this, the room is a big factor in this, and every room is a little bit different. So if we go to the next slide here, one thing that you need to consider is the frequency response impact of the acoustics of the room. And in some cases, you'll want to use a low cut filter, a low roll off filter, to get rid of some low end. And it's going to depend on the room as to whether or not this is a problem. In the when you use the MXA 910 for voice lift, you often needed to get rid of quite a bit of low end, but the MXA 920 actually has a much more consistent pickup pattern even at lower frequencies. So you won't need to do it for gain before feedback reasons, but you might want to just to get rid of any sort of low frequency ambient room rumble that's noticeable in the system. So your corner frequency is something you'll have to experiment with a little bit. Might be 100, might be 150 hertz, who knows. Second, auto mixer styles. You can select a couple of different styles of auto mixer in our products. You'll want to use the gating version of the automatic mixer, which means microphones are on or they're off. You don't want to use a gain sharing system because that's kind of got a more modulated gain structure of different microphones, which is a little less predictable for the system. So the standard gating system works great here. So that's the one you want to choose when you're setting up the system. Now, of course, we've been talking about an installed room. So what do you do when you're doing something that's a portable meeting or a temporary meeting? Or a room that doesn't allow for any installation. And there's actually a different solution we have that works for that, right, Ben?
Yeah, so the MXCW range of products from Shure is a wireless conference product that you can see on the table here. That'll give you your microphone pickup at the participant as well as a loudspeaker, so that if you did need portable voice lift, you can roll this system out and have it up and running in a couple of minutes with up to 125 participants in a meeting on a single access point. So it's one of those products that fills a lot of slots for when you've got problem rooms.
Yeah, problem rooms, or we're having a big important meeting and it's in some sort of historic building and we can't drill anything, we can't run any wires, and it's only for 1 week, so we can't install anything anyway. Lots of reasons like that make a system like this really convenient because it's sort of like instant sound system and everybody hears everybody, and you've also got remote control of every microphone so that, if it's a formal meeting and you need to give people permission to speak or control the speaking order or something like that, MXCW can do it all. It's really convenient.
Absolutely.
So that's another option.
And we don't need to worry about PAGNAG with MXCW because the mic and speaker are basically beside each other but separate. They don't hear each other. And that's the way the product was made. So we never have to be concerned about that.
Right. Yep. So that's another option here. All right. And so if you want to read more about this, we are working on a white paper that goes into a little more detail and lays this all out on paper about how to do voice lift and sound reinforcement with ceiling array microphones, because obviously this is one of the things that people like to do with an MXA 920, and we try to make it as convenient as possible. So as soon as that paper is published, you'll find links to it on the Shure website or maybe through the SAI learning portal if you're taking any of our training courses and so forth. And of course, I would be remiss if I didn't mention our award-winning applications engineering and market development teams. You can always call them and say, hey, this is what I'm trying to do. Help talk me through this here. So, and of course, big news, MXA 920s are shipping, so they're available. So if you've got a project that needs this type of microphone for sound reinforcement or voice lift or just video conferencing, they are pretty easy to get now. So we're happy to take out our ordering pencils and take your orders.
Perfect.
And with that, Cheryl, I hope we have some questions. This is the kind of webinar where there ought to be plenty of good questions.
We have quite a few, and we're going to start with a really easy one, and one for me, and that is, that came up right off the bat, will this session be recorded or be available later for download? And as I mentioned at the top of the session, yes, it is being recorded. It will be available for on-demand viewing in about a week or so at shure.com/webinars. We will also send out an email to all of the registrants with a link to that once it's available. So check your email or keep an eye out on shure.com/webinars, and everything will be there. All right, next question, and one for actually you two. Are there RT60 and NC benchmarks to qualify a system for voice lift in addition to the minimum room size?
Not that I'm aware of. I'm sure if we dug up recommendations, we could find them. But based on what we're doing here today, I'm going to go off the PAGNAG calculation as my gut check, right? If I need those measurements down the road, then I would take a look at that. But I don't believe we have any kind of minimum recommended or maximum recommended RT60 numbers.
Okay. Next question, can a voice lift system be used in conjunction with a conference call?
You want to take that one, Chris?
Sure, yes. Next question. Yes, it's been implemented very successfully in lots of rooms where they're doing video conferencing and like a lecture hall, for instance, or distance learning or training room scenario. And they also want some voice lift so that people in the audience can hear each other. And in some cases, people like to be able to switch it on and off so that if you've got a very small group and they're all kind of sitting near the front, then maybe you don't need voice lift then. And so it would be easy on your, room control system to be able to disable that and re-enable it, depending on the need of the day.
Okay.
And I think with all of the products that we discussed here today, those presets are something that's very simple to do, much simpler now than it ever has been.
Awesome. All right. Next question, can you explain the difference between voice lift and a mix-minus system?
Yeah, it is basically, a voice lift is a mix-minus system because you're feeding every zone a mix of the audio except its own zone. So, if I've got 4 zones, then zone A is getting the audio from Zone B, Zone C, and Zone D. So it is a mix-minus system.
Right. How can we make sure the audience rustling and side conversations don't take over from the presenter, specifically for the far end of a call?
Well, I think there's a couple of ways you can do that, right? One is with noise reduction that's built into our products. That's going to help. We can set the threshold for when the mics are going to open, so we can make sure that they're not too sensitive, so that that isn't triggering a load. And then we also have tools built into software like our IMX Room software that is a AI denoiser, that if you did have a group that can't help themselves but type and click their pens and eat chips, we have tools that can take those sounds out of the call as well.
All right. In a large ballroom type space, how does ceiling height play into the ability for ceiling microphones to work for voice lift?
That's a good question. It definitely is a factor, because the farther up in the air the microphone is, the less focused the pickup lobes are going to be and the wider they're going to be. So I think we're definitely talking about conditions like you would for good video conferencing as well, which might be maybe a maximum of 12 feet or so, I think, for the microphone above the floor.
Yeah, the ceiling height then is going to affect your PAGNAG calculation too, right? So the further that microphone is in the ceiling, the better the room has to be for our calculation to work, right? So you're always going to want that mic to be as close as possible to the talker, right? And that's really what we're trying to do by focusing it, is replicating closeness through that tightness, right? If that makes any sense. That's always how I've wrapped my head around it, because being on top of the mic is always better, right? So the further away you get, you're going to need to compensate for that distance by increasing other distances or decreasing your space to the microphone.
Okay. When an MXA 920 is installed in an air handling ceiling, how do we handle the noise created by the in-ceiling HVAC? This was a problem on a site with an MXA 910.
Yeah, again, it's noise reduction and isolation, right? You need to get that the 910, 920 isolated from the grid so that there is no vibration coming through the device. Ultimately, you're going to want to try and fix the HVAC. If we can't correct the HVAC, then we've got to use our digital solutions, whether it's noise reduction or a denoiser.
Okay.
Yeah, and we should point out that on the 920, like the 910, the noise reduction is adjustable. I believe it's a low, medium, and high setting, so you can make it more aggressive if there's more noise to be dealt with.
Right.
Okay. Do you have any recommendations for a sound processor instead of the P300 when using more than two MXA 910 or 920s?
IMX Room. Absolutely. 16 channels, downloadable. Get your free trial at Shure.com today. You can put it on any PC that has an SD drive. So that's really the only requirement, because if a PC is new enough to have an SD drive, it's probably going to have enough processing power to run IMX Room. So download it, give it a shot. On devices like these today, I forgot where I was going with my 920 chat here. You are going to have to bring out individual outputs. So you're going to need a 16 channel license, right? You can't just do it with 8 if you're going to be doing 2 microphones. If you're going to be doing a sound reinforcement where we're using the auto mix output, then we can have just a single output for each 920. It doesn't matter.
Okay. Considering the good pattern control of the MXA 920, has anyone tried it with one of the new broadband cardioid PA systems, such as the D&B SL series, in a traditional-ish LeftRight PA setup?
I have not.
I don't know.
All right. Well, we'll put that on our list to maybe try out.
Yeah, I haven't tried that yet.
All right. Where can I find the PAGNAG calculator?
Good question. It's on the Shure website. I believe it's under support, which is where you find links to user guides and documents and other things like that. And I believe it's under tools.
I believe you're right. Yeah. Yeah. I think there's a software tools or something like that, or online tools section.
Right.
All right. How does the sound reinforcement deal with the delay from wireless microphones and Dante speakers?
Well, it doesn't. right? That's going to be up to us to figure out what latency we have in the room. And that's going to depend on a few things, you know, which wireless frequencies you're using, how much problems there are in the room. You know, like there's a bunch of questions there, and then we would have to adjust the output accordingly for the audience, right? There's 1,000 calculations that are going to go into that, depending on the room and how much delay we need.
Okay. I'm going to answer this next one. Is there coming any other hardware processor solutions coming soon? I'm going to do the old PR answer. We are a private company, so we do not discuss our product roadmap, but we are always working behind the scenes to expand and improve our product lines. So we can't talk about anything we might be working on, but we're always working on something. All right, let's see. Next question.
I'm working on a new circuit design back here on my whiteboard here, which so far looks very promising.
Zoom in. Good luck with that, everybody. All right, next question. You mentioned reducing grid vibration with the 920. Does Shure make or sell something specifically to accomplish this with the MXA 920?
No, we don't. I've found closed cell foam is the best thing you can buy for when installing a 910, 920. I like to put a little between the grid and the mic to isolate it. That comes from I was a loudspeaker guy for a long time before I was a microphone guy. But yeah, and it really is when they're installed properly, that really isn't an issue. The microphones themselves are suspended in the device to help create that isolation. I like to put in a little additional foam there to make sure that there's no rattle in the ceiling itself.
Okay. This next one I might stumble through a little bit, so bear with me. The PAG calculates to have the same sound level for the farthest as nearest, but if we get a PAG lower than NAG, we can still have voice left by not exceeding the PAG. So farthest still has some better sound, but not as the nearest. Does that make sense?
I think I understand that. I think what that person means is that even though the equation might be kind of marginal in a negative direction and says on paper that you can't quite get as much reinforcement as you need, since it's voice lift, something's better than nothing. And so, yeah, you know, a little improvement, even though it's not as much improvement as you want, might be good enough. So, yeah, I think I agree.
Awesome. Thank you. Thanks for figuring that one out, Chris. Can the P300 support voice lift and program audio and video conference?
Well, there is no video function through the P300, and it certainly can handle multiple audio streams if that's what the question is looking for. It can do video conference and voice lift at the same time. It's just routing it. That's essentially what the P300 is doing, right? So
yeah, and I don't see why you couldn't route some program audio through the speakers too.
Right.
Okay. If the coverage is at 9 meters, while the talker is sorry, this one's a little difficult. How is the coverage is 9 meters while the talker at the distance talking at 70 dB level? What will happen? So if it's 9 meters away and the distance and it's a 70 dB level, what will happen, I think is the question.
Well, it will be not as loud as it is right at 9 meters.
There you go.
And if we measure at 4.5 meters, it's going to be 6 dB less at 9 meters, right? Like that's just, I'm not sure. And if we wanted to go through the math on that specific example, we could, but yeah, it's going to be not as loud.
All right. Can you use the MXA 920 or 910 in a traditional LeftRight PA system without noise cancellation? Or LR PA system?
I guess you could. I mean, the microphone would still be mono, so it would be fed to both the left and right channels. So, you know, I guess you'd want a system like that because you'd have some stereo program audio like music or whatever, plus you'd have microphones.
But I guess you could mic a room in stereo with a 920 and just route the left side pickup to the left sound reinforcement speaker and right to the right. You could do that if you wanted to, sure.
All right. Let's see. What is the ideal situation for a ceiling array install, and what types of surfaces are best?
Soft and absorptive are always better, right? Glass, hard surfaces are always going to be a problem because the sound just reflects. And I think everybody knows that immediately. Even if you're not an audio person, you walk into a room and your brain knows this is a bad room, right? As soon as you start talking and you can hear it. So yeah, you're always best for things that are going to absorb sound and not bounce it around the room.
Okay. Could you please elaborate on some of the differences between the MXA 910 versus the 920, and how does the latter improve voice lift?
Yeah, I'll tackle that one. The 920, in addition to having some cool features like automatic coverage areas and mutable coverage areas and so forth, in addition to the traditional steerable coverage, there was some big improvements to the actual array DSP, the actual processing in the microphone that allows the individual pickup areas to be even wider bandwidth. So the sound quality is more natural, especially on the low end. You get more full bandwidth audio and better directionality across a wider bandwidth. So the short way of saying that is it sounds even better and it performs even better in these applications.
Fantastic. Thank you, Chris. I just wanted to let everybody know I have put the link to the PAGNAG calculator into chat, so you should see that and you can be able to copy it or open it in your browser there. Next question, are the network speakers currently shipping?
So technically they are available with about a year lead time. So, you know, and I think we understand that folks are going to need to get jobs done in the next year, and maybe these aren't the right product if you need that in the next year. There are other options out there. So, and it's unfortunate because it's a fantastic product. I love them. They make everything easier because we've got Shure coming into the system, we've got Shure processing the system, and we have Shure on the output of the system. So I know it's my gear from end to end, and I know it works. And it's unfortunate that, you know, we're going to have to stumble through this year without them, but hopefully by this time next year we'll have everything back up and running.
Yeah, and I was going to say, stay in touch with your sales rep or distribution center because, you know, as everybody knows, the supply chain situation is changing from week to week. And so, you know, what we say today could be completely different 2 weeks from now. So, you know, it's definitely getting better. Things are heading in a good direction.
Oh, yeah.
And I'll add on to that, you know, there's so many things that are beyond our control, unfortunately, and that's not an answer people like to hear. But I can say that I know that there are a lot of people from top to bottom behind the scenes that are working hard to try and improve things and improve delivery dates as best as we can. So we hear you. We want you to have our products. Trust me, we're working on it. So
well, and I'd like to point out that the ceiling speaker is without a doubt the worst one as far as a delay goes, right? Everything else, the sun is shining, things are coming up. The speaker, unfortunately, is left in the dark right now. So.
Great. All right, next question. What is the recommended HPF setting for voice lift?
The high pass filter? It's going to depend on. Yeah, it's going to depend on the room, but generally you're going to want to remove as much bottom end as you need to. So it's going to depend on the room.
Okay. And with that, I think we got through all the questions. We had a lot of good ones. So thank you for typing in those questions. If there is a question that we somehow missed or that pops into your head or is about something completely different when it comes to audio, you can always get in touch with our fine folks in the support team by visiting shure.com/contact. Again, that's shure.com/contact. You can fill out that form, open up a ticket. They can answer so many questions, just a really knowledgeable group of guys and gals. So shure.com/contact for any other questions you have. I want to thank everybody so much for joining us today. I hope you learned a little bit of something. I know I sure did. And we hope to see you on the next webinar. Have a great day, everybody.